So here's another quick example. All the light you ever see is the re-emitted light from the electrons making up yourself. It is never the same light coming from a flashlight into your eyes. It's never the same light bouncing off of a mirror. It's never the same light passing through water or a lens or refracting. It's always a brand new light at every point of interference. So the light coming out of the flashlight is propagating at the rate of c. And then the electrons making up the surface of the mirror absorbs that incoming primary, which diminishes to zero, and as an equal and opposite reaction, a secondary re-emission is re-emitted from those same electrons, and that is traveling relative to the surface of the mirror. And then the electrons making up your eye will absorb that again, and a third wave packet will be re-emitted into the rods and cones of your eye, which you will detect and measure that. And if the flashlight is moving towards the mirror, then the light coming from that particular flashlight is traveling c plus the velocity of the flashlight, but by the time the light actually hits the mirror, the electrons making up the mirror will absorb it and re-emit it from its own frame of reference at the velocity of light c again, and then into your eye. So by the time any light ever reaches your eye or a sensor or detector, it will be re-emitted as the frequency of interference between the source and the target, and you will never be able to measure the velocity of that primary. But you can see a flash before one source or another.